So, welcome for our first actual content. Well, it's still not content, it's still more structured discussion. I'd like to do two things today with you. And I guess nobody is angry if we do this quickly. I'd like to talk a little bit about exactly that. Typical structures of papers, something that you probably have already seen. I'm sure you already had a look at some of the papers. You maybe recognize some patterns. I'd like to talk about these patterns, why they are there, what the purpose is, and how these patterns that you find in papers translate to patterns that you will typically find both in a seminar paper as well as in your thesis. Your seminar paper and your thesis are similar yet not identical, and they are similar yet not identical to the typical structure you find in such a scientific publication, right? So there are similarities, but also some crucial differences. In particular, the seminar papers, they are an odd beast. They are sort of an odd mixture, and that needs some discussion. So you know what to shoot for. Right, and once we are done with that, I'd like to switch to the question, how do you read? And what I mean is, how do you read efficiently? How do you read quickly? How can you maximize the bang for the buck you get out of reading papers? Right? That's sort of the two goals I'd like to cover today. Again, if I'm not making sense, please interrupt me. If there's any questions, let me know. I'll be happy to answer to the best of my knowledge. So, sounds like a plan? Let's do that. Excellent. Good. So, you already had a look at some of these papers? A little bit? Maybe those papers here in other seminars, in other contexts. What you noticed some structure, right? What were structural elements that you noticed when you looked at these papers? An abstract, so they all start with an abstract. Say again. Introduction. Literature review. And that's it, done? After literature review, we're done with the paper? The actual stuff, right? The real content. What else? References. Before the reference, you typically have conclusions and future work. Work, singular. Work is an abstract noun, doesn't take a plural. And maybe, sometimes, rarely. Challenges. Yeah, okay, fine, challenges. Okay. Appendices. Sometimes you also have appendices, right? When you have some complicated proof or something that can go in the appendix. And of course, as part of the material, figures, tables, source code listings, stuff like that, right? Okay, let's take this from the top. Let's take this from the very top. Why do people write papers? Oh, sorry, this is still in German. I guess I need to translate that at some point. The rest is in English. This is just this outline slide. Why do people write papers? What's the point? Why do we bother? I mean, our society has puts a lot of money into producing these things, right? These PDFs. Once upon a time, it was actually printed on paper. Right? I remember one conference where they gave us the proceedings, the set of all the papers produced. It was 6 books this thick. 6 telephone books we had to carry back home in the suitcase, right? That was a lot of fun getting that to the airport. Why bother? Why do we do that? To make it available for other people. Excellent. For other researchers, engineers, whoever, right? Once you pay for them, right? Depends how you publish, you have to pay. Why? Why do we want to make this available?
To disperse the information or the work which have been done to a lot of audience, to a lot of selected audience.
To inform the world, the society, humankind about all the great scientific insights, breakthroughs that we have achieved, right? So, on the surface, this is about spreading information. I tell you a secret, this is also about getting famous, right? But never tell anyone, right? So, it's about spreading information, right? And how do you get famous / spread information efficiently? Documenting it, and documenting it how? by documenting it in such a fashion that many people can find it, can read it, even like to read it, even have fun reading it, enjoy reading it, and then using it, right? If you produce stuff that nobody can find, good luck with getting famous, right? If you produce stuff that maybe people can find but is incomprehensibly dense, obscure, obtuse, good luck getting famous, right? So, writing in a legible, easy to read, easy to comprehend fashion is incredibly important. And I don't need to tell that to computer scientists. I usually think so, but I actually do. Because when you write programs, it's the same thing, right? You all have looked in your past, looked at code of other people, right? And sometimes this code is, oh yeah, okay, this makes sense, nice, easy, nicely formatted, well documented. And sometimes you looked at code and said, what's this? Right? Ugh. Same with text. Right? Exactly the same thing with text. If you write text where people go, ew, nobody's going to read that. And this yucky feeling usually is established after 3 to 5 sentences. That quickly happens. So let's take this from the top again. We actually missed one thing. What really, really is at the very top, literally at the top of a paper, before the abstract? A title, right, the title is nice, isn't it? Why do we have a title? What's the point of the title?
Trying to summarize the point.
Trying to summarize the point? Why would you try that?
To let people know whether they want to read it or not.
Let people know whether they want to read this. This is honey, right? You want to catch flies, flies being the other readers, right? Your colleagues, whoever. This is honey to attract flies. You can try it with vinegar. With an ugly, illegible, unreadable title, you catch more flies with honey than with vinegar, right? The same thing. You catch more readers with a nice title than with an obscure title. So what's a good title? What's a good title compared to a bad title? We come up with your first paper, your thesis, etc. What's a good title?
Short and to the point.
To the point. Short, yes, if feasible, but not always feasible. Okay, what should it also be? Think practically. How do people find your papers? Do they go to the lab?
Google it.
Google, exactly. It should be nice to Google. So a typical thing when you come up with an acronym for your project, do something that's unique, something that's not used for, I don't know, Earth. Earth can be a cool thing, spells out something really nice, but nobody will find it in Google, right? So Google friendly. You need to have all the buzzwords, the relevant buzzwords in your title, so that people, when they Google stuff in your field of work, they actually find this. Google will spit it out, right? So very practical points. And informative, right? You need an informative title, so then when people look at it, they think, oh, okay, that might be interesting. Okay, and then they click on it. And then when they click on it, and then what happens? They go to a first landing page, or to a page like, I don't know, IEEE Explorer. You've seen IEEE Explorer? IEEE Explorer, ACM Digital Library, Springer Digital Library, Elsevier. All these collections of papers published by these different organizations, and then you get to the abstract, right? What's the point of the abstract? You came up with the abstract, right? Yeah.
A short note about the entire paper.
Mm-hmm.
Is going to do.
About the entire paper, exactly. So the point of the abstract is to, you've attracted the fly with the title, right? Now you want to suck it in. Right? Now you need to really trap your potential reader. Still is a potential reader. Now you want to trap them in. So an abstract is the entire paper in 200 words or less. The entire paper. So which questions should an abstract answer? There's a typical canon of typical questions that a good abstract should answer.
What is this point?
What is it all about? What's the problem that we address in this paper? What is it all about?
What are the findings?
Yeah, we'll come to the findings a bit later. First, we need to answer two more things.
Why are we doing it?
Why are we doing this, and why is that? Can you detail that? This why are we doing this has two aspects.
How
how comes later. First with letter Y, right? So what's the problem? And now you want to answer why. I would say why has two sub-questions that you should answer before you can, and then you have answered why. Do you work on irrelevant problems? Hopefully not, right? So why is it relevant? Okay, it could be a relevant problem, but still it could be a terrible paper to write because maybe other people have done it. Why is it novel? What's the problem? Why is it relevant? Why is it novel? Right? But then, how do we do it? How do we approach it? What's your method? What are the findings? It's a typical 5 questions. You should answer in an abstract. Maybe 1 sentence, 2 sentences each, something like that, right? Once you've covered that, this is what, and look at yourself when you read that stuff. Look at yourself, what you expect from an abstract when you read it yourself. You, consciously or subconsciously, you want these questions answered. What are they doing? Why is this important? Why is it not? Why has nobody else done this? What are they? How are they approaching the problem? What did they find? What are the results? 250 words or less, please. Right? Writing a good abstract is really tough. You find a lot of abstracts, but all of them are good, right? So this is condensing everything down to the absolute bare minimum and being extremely informative. So when do people read the abstract? When they look at the web page, right? To see, okay, the title sounded interesting. Let me look at the abstract. That's my next filter. When you start your literature search, right, you'll end up looking at 200 titles or something, right? So you feed in Google Search, Google Scholar, blah, 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 and then you come up with 200 papers. You're not going to read all of them, right? You need filters. Your next filter is are the abstracts. 200 words you can still read quickly, right? So that really makes or breaks whether a paper gets famous or not. And you want your own work to be recognized, so you want those abstracts. And a good abstract also is an indicator that the paper has a good chance of being a good paper. No guarantees. Right? What is an abstract not? Which job shouldn't, you cannot put one job onto an abstract.
Doesn't provide proofs.
It surely doesn't provide proofs. I mean from the reading flow. You cannot, let me put it the other way around. You should not expect the reader to have read the abstract when you write the actual paper. When you start with the introduction. A common fallacy, a common problem is that people, when they start writing the introduction and writing the paper, they assume that the readers have also written the abstract. You cannot rely on that. Think of the abstract as something that goes away once people leave the web page. I know it still stays in the PDF, right? But the rest of the paper should stand on its own, even if the abstract were not there. Right? Pretend it's not there. And then you start writing the introduction. Okay, so reader has read the title, the abstract, thinks, okay, great, I'll read that paper later. Puts on a big pile. You're going to put it on a big pile, and then you've got 20 papers. You narrowed your 200s down to 20 papers. Now what? What are you going to do? Are you going to read all these 20 papers, 10 pages each? Are you going to read them all in detail? Just the introduction. Okay, so if you read just the introduction, what do you expect to find in the introduction?
The argument, maybe? Like, what is the argument of the paper?
Yeah. So how about we start from the top again? So shouldn't the introduction, because reading the abstract has happened 3 days ago, right? Now you drag out your pile of papers and now you start reading. Do you read the abstract again? No, you've read it before, right? So it was 3 days ago, but you've forgotten it. So I at least start immediately at the introduction. I don't bother rereading the abstract. So doesn't it make sense, again, to basically answer all these questions in more detail now? What's the problem? What are they doing? Why is it relevant? Why is it new? For the why is it new, you can delegate the details to a following section, the related work section. You can delegate that. But what's the problem? Why is it relevant? How are we approaching that? Explain high level the method. And then if you like, that's a matter of taste, you can also already incorporate the key results. Personally, I think that's a good idea. What you often find since a couple of years, this has become fashionable, is to say that, sort of at the end of the introduction, after laying out all these arguments, you see sort of the author saying, okay, after I told you everything, let me summarize my introduction. My contribution is, or our contribution is, we are, for all these problems, we are going to do this and that. Right? And that's quite nice, right? Then after you've read that, you say, well, okay, that's useful. Well, I'd like to know more about that. This sounds interesting, this sounds fascinating, I want to know that, right? So when you write the introduction, you can steer expectations, right? This is, they are putty in your hands. The reader are putty in your hands, and you can shape their expectations, what they want to see in the rest of the paper, by writing a clever introduction. So again, what's the problem? Why is it relevant? What are we doing? How do we approach that? How do we solve that? What's the key finding? A bit like a murder mystery, right? A good murder mystery can start by saying, the gardener was the murderer, not the waiter. Okay, but then it still can be a good book, right? Similar with such an introduction. So, that's the introduction. So what does a reader know at the end of such an introduction? You know what the problem is. You have an idea how the problem will be approached. You have not necessarily a detailed idea about, is it really new? Your typical academic reader will say, ha, but I saw this problem being addressed 10 years ago by my good friend Peter. Right? Because everybody knows good friends Peter, and they all have done everything, so I've solved this rigorously 10 years ago. Right? So, what's your next section? Related work. Right? Look carefully what this says. It says related work. It does not say a vague list of stuff that other people did, which is what you typically find, right? You typically find in these sections a vague list with some blah, blah, blah sentences summarizing what other people did. Is this informative for a reader? Is this useful? No. What should you write as an author? You should relate that stuff to your work, right? You should explain, okay, Peter Smith, yes indeed, I know about Peter Smith 10 years ago. He worked on a similar problem, but it's a similar problem. It's not exactly the same problem. It differs from our problem by doing blah, 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 right? You related it. You explained the commonality and the differences between what Peter Smith did 10 years ago and what you are doing now. And then even your arrogant know-it-all reader will say, okay, fair enough. Peter did something else, okay? So, relate. That's the key sentence. The key word in this part of the paper is relating. It's not just listing other stuff and summarizing. That's boring. That puts the creative act of recognizing that this is indeed new on the reader. You don't want that. You don't want to rely on the reader to recognize your genius. You tell them. You tell them that this is genius. Because you spill it out by saying, okay, my problem is different from Peter's problem from 10 years ago. I do look at the same problem as John from 5 years ago, but I'm approaching it with a different method. John did something stupid. He used whatever algorithm. We are now using much more clever algorithm, machine learning. Nowadays, everybody's doing machine learning. Right? So it's game-changing, saves the universe, heals cancer, blah, 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 right? So, what else could you do? You could say, right, and some first name, Peter, John, Mary. Mary, 2 years ago, had the same problem with the same method, but there's a flaw in the execution in how Mary approached that, so her results are wrong. Never write that, right? Never write anything negative about other colleagues. They might judge your paper, and then, no. Always be nice, right? Always be nice. There is some chance to improve upon the results from 2 years ago, and we point out possible improvements, right? Always be nice. Etc., right? Now, that's related work. Related work in the sense, what is your competition? What could other people think oh, but this has been solved by Peter, Paul, and Mary. Right? That's what you need to address. You need to take that argument out of the reader's hand by saying, yeah, I know about Peter's work and Paul's work and Mary's work and John's work, etc. And I'll tell you, dear reader, why this is not the case, why I'm doing something new. But that is one part of material you find in a related work section. There's some other part of material you sometimes also find there. What could that be? Stuff that is not related to your own work, but that still might need explaining. That's background information. Sometimes, depending on the paper and depending on the audience, it can be useful to say that, okay, dear reader, I'm going to use method XYZ from another field and apply it to this problem. Then you are not competing against XYZ. But maybe it's still useful to explain XYZ because maybe your reader doesn't know it. Right? So this is not competition. Related work is always competition. This is a service to the reader saying, okay, dear reader, I'll provide some additional information that you might not be familiar with for your convenience. This is your additional information. It makes a lot of sense to separate that, to clearly separate that out in your papers, in your thesis work. What is competition? What is background? It's two different things. Don't mix it up. Right? And it can be useful to set that in separate sections, whatever. Right? Common problem that pops up in thesis work. Not so much in seminars, but once you start writing your thesis, that's often a question that comes up. Okay, so title, abstract, introduction, related work, possibly such a background section. Whether you need that or not depends on the detail. Right? Then comes the actual stuff. Right? Then comes your own material. What do you typically often find? There's now a large variety in these sections, so there's very little to generalize there. But what is often, do you often find in such a in these multiple sections? Well, often you find something about, well, what are my assumptions? What's my model? Okay, I'm assuming the Earth is flat and the moon is made of cheese, and under these assumptions I can prove that, blah, 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 right? So assumptions, models, scenarios, something like that, right? Then often comes the actual idea, the new algorithm, the new approach, the new architecture, blah, 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 right? And then often, at least in the hard parts of computer science, some evaluation. Right? Is it actually good? How good is it compared to your competition? Right? How much did you improve? That's a common question. Now, if in the theory community you are the first guy to prove the NP completeness of some problem, there's no real point of evaluating things, right? If, on the other hand, in my community you come up with, hey, I have a better MAC protocol, I have a better such and such protocol, then every reader will say, yeah, okay, that's what you say, it's better. I want proof. I want arguments for that. And then you need your simulation, your analysis, your experiments, etc., etc. Often statistics. Often saying, okay, yes, I know I cannot prove it rigorously for all cases, but for a large sample, for a large number of representative cases, on average, it's still 20% better. And so on and so forth. There's large variety. And then basically you are done, right? Then your paper is done. You laid out your arguments, you provided the details, you provided proof that you are better, then hero rides off in the sunset. We could stop the paper there, couldn't we? Yeah, we could, we should, but we don't. Instead, what do? We, as the scientific community, conclusions. We slap on a useless section. We add something totally useless and call it conclusion. What does the name say? Conclusion. It says we conclude something, right? We draw conclusions. We say that, okay, from all this, the following follows. Right? This means the following, blah, blah, blah. Because we assume that the Earth is flat and the moon is made of cheese, we could show that mice can live on the moon by throwing them there. So the conclusion would be, let's throw all the mice to the moon, right? They eat the moon and everything is good, right? That would be a conclusion. We can conclude something from our results. Have you ever read such a conclusion? Not about mice and moon and cheese, of course, but Have you ever read a conclusion in a paper? Very rarely. What do people really write? A summary, right? They just write a summary and then pretend it's a conclusion. When in effect, they just write a summary. Do we need a summary? Not really. We got an abstract, that's a summary. We got an introduction that does a good job of being a summary, hopefully. And then yet another summary? Do we need 3 summaries in a paper? Yeah, because people expect it, right? If you have guts, don't write conclusions. If you are a coward and bow to convention, write a summary and call it a conclusion. It isn't, but you'll just confuse people. If you are a lazy coward, you just copy the abstract and turn the order around. That's also often you find verbatim copies of the abstract in the conclusions, right? When I get such a paper, I immediately reject. I don't even bother to read the rest. I know they are lazy and have no ideas, right? Okay, and then of course references and possibly appendices, something like that, right? That's boring stuff. Okay. Oh, somebody wanted to do future work. Who wanted to do future work? Why? Why do you add that? But you have solved all the challenges, haven't you? Some open questions. Okay, why would you share them? So you worked hard to find a solution to a problem, figured out that some parts you couldn't solve, and then you point out your competitors to these hard problems? I know. What was that informative? Really? Okay, show me. You have to show me. I have yet to see a really informative future work section. Usually it's just blah, blah. Yeah, in future work we're going to do. Either it's the stuff, okay, I know that you could do that and you were just too lazy to implement this part of your simulation. Big whoop, yes, thank you, I'm deeply impressed. Or it's, well, and if in the future we can prove P equals NP, then everything is different. So personally, I'm not a fan of future work. I think it's just hand waving and just blah, blah, blah. And actually, more and more papers simply ignore that. Okay, if you look at classic papers in real sciences like physics, chemistry, etc. For example, read Einstein, his famous papers from 1905, his 4 famous papers from 1905, and have a look at them. They are very short and revolutionized physics. There's no introduction, there's no abstract, there's no conclusion. This is just to the point, bang. First sentence starts off right away. Right? We are sort of a weird science as computer science, computer engineering. We're a bit of a weird science. We have such a broad variety in our audiences to whom we write, for whom we write, that we need all this introductory stuff. And sometimes this really gets overboard. Sometimes these introductions start, with in the beginning, God created the internet, and by the way, the internet is useful, and by the way, wireless communication is useful as well. In case you haven't noticed, your smartphone is wireless, and what would happen if you used wireless technology also to connect laptops? I mean, come on, guys, it's 2019, right? Another favorite of mine is recent advances in microelectronic technology have made it possible to shrink down processing to on a single chip. Please, I mean, this is 30 years ago, right? And still, people write recent advances. Yeah, when a paper starts with recent advances, you know it's crap. Don't bother to read it. It's an incredibly reliable indicator. Okay. So, okay, that's the structure and the main points of all your sections in the paper. Now, what does that mean for your own write-up? As long as we are talking your thesis, your master thesis paper, this is still pretty much true. Right? It's all a bit longer. Your typical scientific publication is something between 5 and 10 pages. If you write a thesis with 5 to 10 pages, I hope you are a genius. Right? length is not everything, but you need some space usually to lay out the argument and so on. So for a thesis, this all is pretty much valid. Yeah, blah, blah, blah. So you still got all that, titled, abstract. I think in the past we actually had a requirement at some point that the abstract needs to be in German and English. I think this is no longer true, except for PhD theses. There, it's still the case, it needs to be German and English, but just the abstract. So, cool. Introduction, related work, main body, conclusion, future, yeah, okay, we covered all that. There on the slides, there is some additional, basically what I said is written down here. Right, background versus competition in the related work. There is some debate about location in text. So some people, very rarely, it's sort of a dying version, like to do the related work towards the end of the paper, before the conclusions. Actually, personally, I like that. Also, when I read a paper, I usually skip over related work and read the actual stuff first. Why? Because only then can I really appreciate the relation, the competition aspects, right? So I only then have understood what they are really doing and can then sort of lay their argument against what is in the literature. But by now, it's totally typical to have it sort of as the second section of your paper, also in your thesis work. Most of your advisors will look at you quite funny if you put the related work towards the end. Personally, I think it makes a lot of sense, but matter of taste. Also, what you find typically in electrical engineering disciplines, there it's much more common to weave the related work material into the introduction, not to have separate sections, but to sort of integrate that in the line of flow of the introduction. More common there. In computer science, you actually get slapped around the face if you do that sometimes. I had papers rejected by saying, yeah, but it doesn't have a related work section. Yeah, it had related work discussed in the introduction. It wasn't split out into separate sections. Come on, guys. Anyway, scientists are an incredibly conservative bunch. You're probably the worst that's on the globe, right? So anything that deviates from expectation, go away. What are you doing? So stick to conventions. It's sort of the typical thing. Right. Main body, no uniform structure, heavy variation depending on your methods, on your problem, etc. Very difficult to generalize. And summary, if you just comply with convention, much stronger conclusion. What does it mean? Put it into perspective. Explain what you achieved, what is still there. Okay. Fair enough? Scientific publication, your thesis, all follow this general pattern. Now, what does this mean for a seminar? For your seminar write-up? Can you apply this? Can you apply this part here, this structure, this blueprint? Can you apply that to a seminar? Does that make sense? What you're doing here? There's one part in here that makes no sense for a seminar paper. No, abstract of course makes sense. Future work makes no sense, but future work never makes sense, so that's nothing specific. Well, in a way, but I would say main body makes no sense. Main body is the part where you explain your own creative original insights. Do you have any original insights? I'm not stopping you, right? If you have, that's great, but I don't require that. I don't require you from doing own creative original work for such a seminar. A seminar is about discussing what other people did. In a sense, in a loose analogy, a seminar paper is a big related work section. right? It's a big section about, okay, we have an introduction, a problem area. What's the problem? Why is it interesting? Sure, that's both in every paper as well as in a seminar paper. It also could, an introduction for a seminar could also talk about, well, there is possible solution options. What are good solutions? What are requirements? How can I distinguish a good solution from a bad solution? What's a good architecture versus a bad architecture? What would I like to see in a solution? That's also nice to put into an introduction in general also, but here for a seminar in particular. And then basically you go through, okay, option 1, option 2, option 3, option 4. So in a very loose sense, it's just a big related work section. Now, in a loose sense, right? Don't start doing now heading related work and then have many subheadings. This makes no sense, right? So it's just some sort of analogy there. So your typical seminar has no own work. So blown up related work section, since there's no own section, but still well, yes, a conclusion in the sense of I have done this, but an extensive discussion, comparison, putting into context, comparing, is the one good, is the one better than the other, that clearly is part of a seminar paper, right? So the pattern is slightly different, right? A typical pattern for a seminar, I said seminars are not beat. Title, abstract, yes, of course. Introduction, what's a problem that you want to solve? Maybe possible approaches roughly outlined. Requirements for a good solution. What would we like to have at the end? And then you can explain solution 1, solution 2, whatever you decide upon, approach, whatever. And then the thing for which you get a good grade or a very good grade, as opposed to just passing, is this. The comparison and the discussion of these solutions with respect to these requirements. That's why you need the requirements here, because otherwise how can you say that this one is better than that one? If your requirement is it should be more colorful, it should have more unicorns in the logo, then you end up with different comparisons. So you need the requirements, what's good, and then you need the discussion. A very blunt, a very, very broad pen approach to that could be, very simplistically, to say, okay, I have solution 1, 2, 3. These are columns in a table. My requirement 1, 2, 3, A, B, C, D are rows in a table, and then you do pluses and minuses. That's sort of the very simplistic approach, but it's better than nothing, right? It's better than nothing. Ideally, I want more reasoned arguments. I want a better explanation why, because of this property of solution 1 compared to solution 2, solution 1 is better with respect to requirement A. But with respect to requirement B, because of the following properties, solution 2 is indeed better. Right? That's the type of thing I'd like to see. Why? Because I hate you? Well, not only, right? The main argument is because this is what your boss is going to have you write once you are in a company. Think of a procurement process, right? You need a problem solved. You need to buy some stuff to solve problem X, right? That has certain requirements, and you have a couple of options from different vendors, and now I want an argument. I want to know why we should buy option 2. And not just because it has more unicorns on the label, right? And the website is fancier. I want concrete arguments, and this is what this is all about. I want concrete arguments, why this, not that, for these requirements. Okay? Makes sense? So this is so that later on, in your job, in a company, you write better input to your boss. Very bluntly. Yes, please.
So within the solutions, under the solutions subheadings, we don't compare to the previous solution. We discuss.
I wouldn't. I mean, that's one possible approach. If you compare here 2 to 1, then here you have to compare 3 to 2 and 1, and 4 you have to compare to 3, 2 and 1, and I think that gets cumbersome. I'm not going to stop you if for whatever reason you think that makes sense. Maybe it does, okay. Personally, I would here just give a brief narrative, a brief summary. This is indeed a summary. How this works, what are the peculiarities, the particular cool things, the unique selling points, right? And then I do all the discussion in a separate section, joint. Personally, I find that easier to read, but dare to deviate. If you think because of the papers you have, maybe another structure makes sense, go for it. If a good idea, if you think this is nicer, go for it. Talk to your advisor, right? It's a good, usually a good idea. Talk to your advisor first, and then they probably will say, okay, go for it, or maybe they point out, yeah, have you thought about this aspect, right? Yes, please.
Is it okay that I compare my own solution with the already derived solution from other person?
If you have your own solution, yes, absolutely. That you should do, for example, in your master thesis. By all means, you must do that. Here, do you have your own solution in a seminar? No. Right? That's my point. That's my point. I don't expect you to develop your own solution. So you're sort of the neutral judge. Think of yourself as the referee between all these competing ideas. And then give me a recommendation. Which should I buy? Should I buy 1, 2, or 3? And because you don't have your own solution, you have no stakes in the game, you can be neutral. Isn't that nice? In your master thesis, you probably want to defend your own stuff, right? You want to look good. Here, who cares? I have no stakes in solution 1, 2, or 3. I can be absolutely neutral. Okay. With that being said, and at the risk of repeating myself, let me point out one thing. In a seminar paper, it makes 0 sense to have a section related work. It's always related work. There's no point in having related work. As opposed to what? It's all related work, right? It's just silly. I bet I'll see 2 or 3 related work papers. So we'll see, right? Okay. So far, so good? High level, clear? Excellent. Okay, then let's go a little bit into more technicalities, and we'll come to those back a little later. Required, there's a typo. Citations, correct citations. Why do people cite? Why do you cite something? To show it's not your work, yes. Intellectual honesty, a hat tip to the authors, to the actual inventor. Why else? For that, it would be good enough to say, okay, the stuff in italics is not mine. You do more than that.
Where to find it.
Where to find it, exactly. You give enough information, you give the reader enough information to say that, okay, this part here discusses Peter, Paul's, and Mary's work, and if you want to read up on that more in detail, go to reference 5. There you can find everything. Okay? What do you need to write down for reference 5 so I can indeed find it? Title? Journal? Journal, conference, wherever? Year.
Page numbers.
Maybe page numbers if it still exists. Many conferences no longer have page numbers. Yeah, they're just PDFs. They have no... They all have page number 1 to 7. Never noticed how often papers start with page number 1? Because they don't bother to do a consecutive page number, and it makes total sense. One important thing is missing. Author names, right? Would be nice. Hey, Peter, Paul, and Mary. And ideally, what else?
Sometimes the URL.
A URL, and in particular, what format of a URL is particularly useful?
Short version,
A DOI, exactly. What's a DOI? It's obviously an acronym, DOI, Document Object Identifier. It's a unique numbering system that every paper has a unique number, and you can find it just using this number. In principle, if we actually were a digitalized society and had embraced that, the DOI is all that you would need to state. In practice, old people like myself look at it and say, what's that? Where's the page number? I had a long fight with one of my colleagues here about page numbers in a proposal when I said, this is stupid, it makes no sense, these conferences have no page numbers. No, we must have page numbers. And we've killed him. Anyway, DOIs. Not commonly accepted, but more and more. Locations, blah blah blah, right? So that's your bibliographic information. What do you need to state in order for the reader to find it? Now, you need to link this to the point in the text where it appears, right? In CS, EE, CE, many sciences, you typically find this style. Square brackets, number, and the number points to the so-and-so entry in your reference list, right? That's the typical style. However, there's no uniform style across sciences. Physics guys, for example, use the so-called author-year style, author, comma, year in which it appeared in parentheses in the text. So, convention.
I studied at an American university, and in my scientific writing class, they told us to even write the paragraph number in text. So we would say, for example, Smith, P, and then we used to do MLA style citations.
Okay. So the page number or paragraph number.
And sometimes in journal articles, just paragraph numbers.
Okay, nothing wrong with that. Seems a bit overkill to me. Where I would agree where this is really necessary is if you refer figures or tables. Then you want to make clear, I'm referring to table 5 out of reference 1, right? Not table 3 or 4, 5. Figures, tables, listings, you want to be very specific. If you refer to a textbook, then I would also agree. Textbook can be 1,500 pages. I'm not going to read all of them. Please tell me which page I should look at. Right? Then you can either say, okay, section 20.5 in textbook such and such, or pages from here to there. Then I would agree. In a typical paper, nothing wrong with that. I would not insist on that. It's also rare you see that in publications. Okay, do you do this manually? Of course not, right? That's why you have decent tools, in particular LaTeX and Bibtex. Okay, guys, shows of hands. Who is familiar with LaTeX? Kind of. No. You'll learn something useful for your life. I guarantee that. You might hate it at the start, but it'll grow. It grows on you. LaTeX comes with a separate tool chain that's called Bibtex, BibLaTeX, Biber for the more modern version, that has an important idea, namely the separation of content and layout. Similar to what you find in an HTML document, right? In an HTML document, you describe the content. This is a heading 1. You don't say it's a heading 1 that is in 32-point font in red on green background. That's layout. So you separate this out. Same idea. You describe the content. You semantically state this here is the list of authors, and this string here is the title of the paper, and this here is the title of the procedure, and this is the year, etc., etc. And then you give this to a separate tool that produces a nicely laid out version of that. This is Bibtex or Biber as the typical tool chain for that. If necessary, we can do a short demo or short intro on that. Maybe not tonight, but if you guys are unfamiliar with that, run into problems, let me know. There's also tons of material online. Tutorial LaTeX gets you plenty of stuff for that. So usually not too difficult. Right. So what do you cite? You cite anything that you actually use, figures, tables, etc., etc. If you copy something in the caption, you put that in. Okay, this is figure 5 from reference 7. Whenever you quote something verbatim, you of course also cite that. How do you quote correctly? Italics and typically quotation marks at the start and end. Quotation marks start, end, and italics in the middle, followed by reference 7. Possibly then, if you are actually verbatim, then I would agree then you point to page 7, something like that. Right. And again, tool chain. I mentioned this Mendeley thing yesterday. That also plays very nicely with this tooling, right? So ideally, the ideal tool chain is and workflow is something. You get your PDF from IEEE Explore or someplace. You get the PDF. You drag the PDF into Mendeley. Mendeley looks at the PDF and sees, aha, this is paper such and such. Actually, it works via the DOI embedded into the PDF. It drags, it pulls in the bibliographic information via the DOI from the IEEE Explorer site, fills it. Come on, I'll show you. Why am I talking so much here? So this looks something like that. I don't know. Let's pick something. And then you get all this information here. And then this you can export into a Bibtex file and use that in your files. Very, very nice workflow, very convenient to use.
Also has show related work. So in its database, you just click right and show related work to that paper.
Oh, does it? How do I do that?
Just right click on the title and it should have show related work. Related documents.
Oh, that's new. Oh, interesting. I didn't know that. Cool. Well, maybe there's more than these 7. But it's a start. It's definitely a start to get this flow started. We'll talk about that in a second. Let me come back to the processing. Yeah, that we'll get later. And since we agreed we don't need summaries, we can skip that. So, indeed, we are back here. So, maybe before we get into this is sort of the second part. Any questions so far? You have an idea how your text should look like? What should go into which sections? Okay, great. Now, second part, where do you find material? So basically, we provided you some starting points, right? We provided you with some starting points to start searching. But since searching for material is the essence of science and engineering work later on, we expect you to search. Now, how do you search? Google Scholar, Google in general, IEEE Explore, ACM Digital Library. You're all familiar with these, or should I write something down? So these are typical websites for that. The point is you can search into directions, right? You can search sort of from the perspective of the paper, you can search in its past and into its future, right? Searching into its past is not so hard, right? A good paper has a list of references stating everything that it builds upon, and then you can sort of go from the paper into its past into the prior work for that. Okay, and that in principle you could do by just looking at the PDFs and searching sort of all its backward references, and you have sort of the tree of its entire past by jumping from pointer to pointer, in principle. Searching into the future is more difficult, right? Basically, you want to know all the papers that refer to this. Manually, practically impossible. For that, you need such tools. Mendeley, Explorer, IEEE Explorer, they all give you this, who is referencing this paper. Of course, for a paper that's 2 months old, you find nothing, right? But that's okay. This is not to be expected. So you do the past and the future, and then this starts branching out. And if you do the future, from these future papers, you could go back to the past, and at some point, ideally, knock on wood, ideally this converges to a stable set of material. It won't, but that's sort of the ideal case. If you have a small community, small sub-community of computer science, maybe that actually happens. The theory guys have a fair chance of that happening. For us, this is practically not feasible. So, doing that, doing the past and the future reference hunting, you quickly come up with hundreds of papers. Okay? How do you decide how to filter? How do you weed out, how do you separate the wheat from the chaff? What's a quality indicator for a paper?
Where it's published?
Where is it published? Okay. How do you recognize a good publication from a venue from a bad publication venue?
Impact factor.
Impact factor? What's an impact factor?
How much this journal article, how much of these journal articles are referenced?
Exactly. Impact factor of a journal, for example, say transactions on networking. IEEE ACM joint transaction on networking, the top-notch journal in my field. divide that by and do the average, right? That's your impact factor. On average, how many citations does a paper in this value have? And, well, you would expect a high impact factor is a quality indicator. The higher the better. Any guesses what the typical impact factor is for a leading journal? Let's say maybe not transactional networking, let's say maybe take one layer down, say transactional network and service management, sort of second ranked journal. How often is a paper cited on average? Any gut feeling? Very high quality, not top-notch journal. 1, 10, 100, 1,000?
Depends on the impact factor.
Well, that's what the impact factor is. I'm asking you to just take a guess, random gut feeling guess what the impact factor is of such a top-ranked, not top-notch journal. 1,000 citations for one paper.
Maybe
10.
10.
3 to 4. 3 to 4. TNSM, sort of this almost first year, a little down, has an impact factor of 3.5, and they were really happy to have it increased from 3 to 3.5 over 2 years now. They touted this, that big achievement. Right? So citations are a rare commodity because there's so much papers out there. If you look at the big conferences like Infocom, flagship IEEE's flagship conference in networking, Infocom, typically publishes every year 1,200, 1,400 papers. And then you have the even bigger conferences like ICC, International Conference on Communications, 2,000, 2,500 publications per year. These are huge conferences. They run a week with 12, 14 tracks in parallel. So you have 10, 12 meeting rooms where you have talks from 8 o'clock in the morning to 6 o'clock in the evening. Every time somebody is giving a talk, 10 people in parallel to 10 different audiences. Networking is a huge field. And then if you divide that by number of publications, divide by number of citations, you do 3.5 is a pretty good impact factor in our field. For something like science or nature, I actually don't know the impact factor, but this is orders of magnitude higher. Right, so impact factor of a journal. General reputation. So you probably don't bother to look up all these impact factors. If it has something like IEEE, ACM, and transaction in the title, it has a good chance of being good. Other than that, conferences, how can you tell a good conference from a bad conference? Well, you probably can't, right? What is better, ACM SIGCOMM or IEEE WSEAS? You heard of neither before, right? How can you tell? Impossible. Right? So you can again look at websites or so on. At some point, it's just it boils down to having experience, to know these conferences, and then you look at that. So okay, so that's one information you can pull in. What else could you pull in? What's an indicator that this might be a paper worthwhile to look at, to read? Not the impact factor of the venue.
Scientific title, maybe?
The title, sure, yeah, but I'm looking at sort of stuff that you can apply without even looking at semantics. Objective, quote unquote, objective numbers. So impact factor is for the entire journal, conference, whatever. If you break this down to the individual paper.
Because of how often this paper was cited.
Exactly, the number of citations for the individual paper. If this was cited 2 times and it's a 10-year-old paper, then obviously nobody cared, right? If it has 500 citations, oh boy, that's a high impact paper. To give you an idea, a high impact paper in our field, 1,000 citations is spectacular. You'll find very few papers in CS with 4-digit citation numbers. Triple-digit citations is already pretty good. 20 citations, 30 citations can be okay for younger papers. Anything below 10, don't bother. Unless it's really a new paper from last year, then that may be okay. Other than that, don't even bother. Probably not worth reading. Right, authors. At some point you start recognizing author names. Some people keep reappearing. Jennifer Rexford is such a name that will reappear and reappear in many of the papers you might read. Very influential author in that field, professor at Princeton. She's writing tons of papers and they all are pretty good. So at some point you start recognizing author names. And usually they appear not further. The order of the author names, is that meaningful or not?
Yes.
Nodding. Actually, depends. In some fields, it means nothing, and they go alphabetic, with the idea that everybody contributed equally. In other fields, first author, major contributor, last author, the guy who provided the money, never read the paper, and the guys in the middle sort of helped during coffee break, right? It's sort of the rough convention, right? So I usually appear last. Sometimes I still read papers with my name on it. Right. There's sometimes you also find acknowledgement sections, right? This is for the people you have to mention because they gave the money but didn't do anything at all, right? So they don't show up in the paper list but in the acknowledgement list. Acquaintance of mine is working in physics, gravity wave detection, this LiDAR thing. So his name is on this LiDAR, no, not LiDAR, sorry, what's it called? This gravitational wave detection thing from 2 years ago or so. His name is on that paper that described that. God, what's it called? I forgot. Anyway, yeah, his name is on the paper, but so is the name of 1,500 other people. Right? The physics guys sometimes have these crazy long author lists. The CERN Hadron Collider, Large Hadron Collider papers. I think one paper had 3,000 authors or something. Okay, hard to tell who made which amount of contribution there. Right? These are mostly political papers, right? So at some point, don't bother. Okay, so impact factor, citation count, author names, where it appeared. And then you need, so this gives you a first filter, and then you actually need to look at content. Then you need to look at the title. Does it sound interesting? Hello, good title design, right? You attract honey. And abstract. For a first reading, don't even bother. For this first filter, don't bother to look at the content. You have no time. There's too many papers for that. You don't have time. You need quick filters to quickly reject, to quickly discard papers. Okay, that's great. So you did your forward and backward search. You still got your pile of papers sitting there. And it's now down to, after you looked at the abstract and so on, now it's down to 30 papers. Which you think after reading the abstract, yeah, could be, maybe. What do you do next?
Headings and references.
Sections. Section headers? Yeah. What else? What else is a very quick way of checking such a paper? You want something fast, right? You don't want to spend your entire weekend.
Yeah. References?
References, what do you look for in the references? Whether there are any? Yeah, I surely hope so.
Whether you recognize any.
Do you recognize anything? If it's about a field where you have some idea what's it all about, you would probably expect some papers to be cited, the landmark papers in the field, and if they appear, good. If they don't appear, cast a shadow of a doubt on the paper, right? Okay, but for that, again, you need experience. You need to already be familiar with the field to some degree. What else can you quickly check? Yeah, but for that you actually need to read, right? I want you to have, I want you to spare reading for at least one more step. So if you don't read, tables, pictures, figures, illustrations, very quick checking, right? You just look at the figures. Just look at the figures. So that makes sense, right? This is, again, we're talking quick filter. Don't be overly conservative, be liberal, but still try to filter. If you look at the figures and the architecture sketch makes no sense if you don't comprehend it, if it's silly, if at the end the evaluation, if you have a quantitative paper, they all boil down to having something on a horizontal axis and something on a vertical axis, right? And then they have some plots. And then you look at what's on this axis and what's on that axis. By the way, there is no such thing as an x-axis and a y-axis. This makes zero sense, right? There is a time axis, a distance axis, a latency axis, and there's an energy or a throughput or latency axis, but there's no x and y. This is high school misuse of something. So you look at these axes, you look at the figures, you look at the comparison cases, you also see that quickly, so the own approach, standard approach X, Y, Z. If you don't recognize what the standard approach is, or if there is no comparison, also bad sign, very bad sign. Hey, I did my own approach, and look, my curve looks nice. Good for you, here's a cookie, go home. If you don't compare yourself against others, nobody should take you serious. So that's also very quick checking. Does this make sense? Is this plausible? If yes, okay, it stays on the pile. If no, throw it away. There's enough papers to read. You throw away stuff quick. Okay, you're down from 30 to 20. Now you need to read. Now you need to start reading. How do you read? Again, no time, right? It's weekend. You want to do other stuff. Maybe the weather is even nice. Unlikely, but let's assume for the sake of argument the weather is nice.
Just light reading, no proofs.
Light reading. Light reading is a good way of doing that. You read the introduction and maybe the conclusions. Maybe. I wouldn't bother. Read the introduction. And again, skim the rest. If the introduction makes sense, okay, it stays on the pile. If the introduction is wishy-washy, unclear, if they cannot tell you on the first page what the paper is all about, it's probably not worth the bother, right? Again, throw it away. Then read everything, but just skim over it. Don't even try to comprehend stuff. Don't try to understand proofs. Don't try to understand the details. You have no time for that. Right? Quickly read through, skip entire paragraphs, no problem. Just sanity checks. Does it make sense? Is it plausible? And then you're down to 10 papers. And then I'm afraid then you have to read it. And you actually need to read whether it makes sense. And there's no getting that. But my only point that I'm trying to make here is don't fall into a common trap of trying to Don't fall into the common trap of trying to read everything first time completely. No time for that. It makes no sense. So try to maximize your bang for the buck. If you want to read up on that some more, this is something that I actually suggest you do read in more detail. Efficient reading of papers in science and technology nicely explains all what I basically stole from there. Well, also think about why do you read? Do you just want an overview? Do you want to understand something in detail? The purpose of reading modifies how you read. And that's the idea here, right? Yeah, we talked about that. We talked about the citation graph. There's a couple links if you're unsure where to find that. The usual suspects, typical venues. Venues, the same journals, the same set of journals, the same set of conferences gives you ideas for to do that. Yeah. Oh, and by the way, I strongly, really, in your own interest, I strongly ask you and encourage you to use tools to do that. Be organized. Keep your PDFs in an organized fashion. Annotate them. Scribble in them. If you do it manually on paper, or if you do it electronically with an iPad or something, I don't care. But keep them organized. Use something like Mendeley or other tools. There's plenty of alternatives. Use something like that. Keep your bibliographic information together with it. Keep your notes with it. And once you start actually reading seriously, annotate your PDFs. Mark up, put question marks there. For the seminar, it's probably still okay because you don't have to deal with so many papers. But when you start doing your master thesis, you will hate yourself if you don't do it. Because typically there's 5 months in between. At the start of your thesis, you read everything, then you forget it, you put it aside, you never look at it again. 5 months later, you have to start writing your report. And then there's the related work section, and then you, oh, shit. I remember reading something. I need to go, but now I have to do it all over again. Right? In any case, once it's master thesis time, start writing early. Every year it happens with a couple guys, they start writing too late. Oh, I'm good at writing, no problem. 2 weeks. 2 weeks at the end of my 2 weeks before the deadline, I'll start writing. When somebody comes with that attitude, I know that will fail. We tell them every week, start early. Sometimes you've got people you can't help. Right? Start early, in particular related work stuff. This doesn't change a lot. You can write that early on. You don't need to come back after you've forgotten it and have to redo everything. Please, please, please do that early. Right, and then we have this narrowing it down, reading for breath, introduction, section headings, tables, figures, things that you can scan quickly. Look at credibility. Who wrote it? Are these known people? Where was published? Reputation of the venue? Bibliography? How extensive? Is current work cited? Are classical papers cited? And then you read in earnest. For whatever is left over, you read in earnest. And the attitude with that, with what you read, is you don't believe a single word. This is not holy writ. This is nonsense. Every paper is guilty until proven innocent. It's useless until proven valuable. Right? The attitude is skepticism. It's doubt, it's mistrust. A paper needs to prove itself. So when you read, challenge every word you read. Every sentence should be followed by a, that's what you say, kind of mental attitude. Right? So examine the assumptions. Do they make sense? Is this plausible? Right? The moon is made of cheese and the earth is flat? Yeah, sure. Then I believe you can prove anything. But I don't care whether you can prove that. Examine the methods. Do the methods make sense? Examine statistics. You can do so many dirty tricks with statistics if you know what you're doing. But you can also recognize them. It's not too hard to recognize them. Typical example is, okay. Oh, that sounds like permanent. Nobody can see that, I guess, right? This is better than that. If you see that in a paper, what do you do with this paper? Why? Statistically, not a valid conclusion, not at this point. What do you absolutely need to have in an empirical evaluation-based paper? Confidence intervals. A measure of variability, a measure of variance. If you don't have that, come on, this is silly. Don't bother me with nonsense. So, statistics. Do they do an error analysis? Do they have an analysis of statistical significance? This is not relevant for your proof-oriented papers, right? The theory guys, we shall prove the following, they don't need to bother with that. But anybody that's doing empirical work, experimental work, if you don't look at the statistics of your results, you're silly. Right? Conclusions, etc., etc. And as I said earlier, take notes. React to what you've read. Take notes, challenge it, remember. Put it in your Mendeley annotation fields. Put it in a text file so that you can find it again. You just hate yourself. Summarize tables, summarize graphs, so you have a quick way of coming back to that information. Right, in a consistent place. Okay. Yeah, that's pretty much all I wanted to say on that. Well, what to read, we've covered that. Forward pointing, backward pointing, I guess that's already, yeah, we said all that. Any questions up to here? No? So, yeah, please.
Can we have mock paper submission for you?
One more time?
Mock paper.
A mock paper, mock-up paper. You mean from a previous seminar? Yeah, that's always a bit tricky because that's data protection. So I can't really grab somebody from some paper from another student. Maybe I can ask my PhD students. Some of them in the past did seminars with us. Maybe I need to explicitly agree. Then they need to explicitly agree. So you want some idea how much material should go in the session. Yeah, talk to your advisors. Usual recommendation. Your advisors will help you. They will tell you that, okay, this is enough to pass, but you won't get a good grade, or this is actually pretty good. Listen to their feedback. But I'll see whether I can find something. Right? So, to summarize, structure of a seminar paper. Something like a big related work part section of a real paper. Don't be literal about that. Think about the structure. Problem statement, requirements for good solutions, comparison of brief description of different solutions, and in particular the comparison of these different solutions with regard to the requirements you started at the beginning. You close the loop to the start of your paper. Right? That gives you a good grade. Paper chasing, reference hunting, backward forwards, in the past into the future, filtering out via venue, impact, credibility, plausibility checks, quickly narrowing it down, a long list of possible papers to something that is manageable, 5 to 10 or something. Right? And once you are down to 5 to 10, always talk to your advisors, but once you're down to 5 to 10, this is your first milestone. Right? This is your first milestone. Ideally, take a Bibtex file, put that in an email, say, okay, this and that I looked at. These are the 10 papers I considered seriously. And out of these, I think paper 1, 5, 7, 8, and 9 are the ones I'm going to use for my actual writing. That's your first milestone. In 2.5 weeks, something like that, if I remember correctly. Okay? I agree. It's late. No further questions?
Is there any limit or number of pages?
Upper limit or lower limit?
Lower limit.
Lower limit.
My usual answer to that is as short as possible, as long as necessary. Nobody wants to read fluff. Nobody wants to read blah blah. I'm not going to say 5, 8, or whatever. I'm not going to give you complete knowledge. Listen to your advisors. And at some point you start feeling that, okay, this is not enough. I need to explain this better. Or come on, I'm blabbering here. Don't blabber. This is not the point. If you give me 20 pages full of blabbering, you still fail. Right? I don't want to read that. Always think of somebody needs to read that, and they spend work time, right? Or they spend even their spare time. They spend their Saturday afternoons. Do I want my advisor to have to read this text on a Saturday afternoon? Ask yourself this, right? And if you say, yeah, this is interesting, or if you say, nah, I'm just putting in stuff to get more pages. If you have that impression yourself, you're doing something wrong.
And the second thing is that we often tend to repeat things. I mean, something that's already in the introduction or probably in the abstract or somewhere in the beginning of the paper, and we have a section where the same thing has to be repeated, but like we get strange feeling that okay, I've already written this, probably should have put it in a different word, or should I repeat it? Will it make sense to repeat it?
Usually, no. If you just really repeat it, it's usually a better idea to say, well, as already has been pointed out in section 3.2, and continue. Maybe sometimes it's necessary to, if there's a lot of text in between, maybe it's sometimes useful to remind the reader, but then don't repeat it verbatim, same thing, shorten it. Usually work with references, cross-referencing inside your text. Nobody wants to read the same stuff 3 times. It's boring. Think of me sitting Saturday afternoon on my sofa, on my couch at home. You think I'm happy to have to read the same stuff 3 times? No. Right? That's actually, this is a pretty good check, right? Imagine me sitting there and check whether you think I'm happy or not. Right? Okay? When shall we meet again? Next Friday is not such a good idea. It's a holiday, so we'll have a hard time finding any spot. We could do Thursday evening instead, or Thursday late afternoon or something. Let's see. So that would be Thursday the 18th. Maybe not 6 o'clock in the evening. How about 4?
I have a class at 10:00, so I might arrive 4:15 if we do it.
Okay, if you do it on camera, 4:15 is fine as well.
We have German classes.
Oh, until 6? And before, when does it start? How about 2 o'clock on Thursday? 2 to 4? No?
Anything before.
Say again?
Anything before 13, like 1 o'clock.
10 to 12? Okay, no. Okay, let's keep searching. Wednesday morning. No? Okay. No, okay. Tuesday afternoon. Tuesday evening? Like 6. When's your German class lasts to 6? Tuesday 6 o'clock. Again, not ideal, but what can we do? Probably better than Thursday 6 o'clock before the holiday. Tuesday 6 o'clock it is.
Having a meeting so soon, I don't think we will have any progress to show.
Oh, you don't need progress. It's just me talking, right? No. I have a couple concrete things I want to go through with you, so no need for you to come with anything. Next time we'll talk about a little bit more text organization and actually writing. How to write. And we'll do text organization in smaller, on sort of paragraph level. How do you get... The English guys would call this technical writing. Something that we don't teach much, so we'll just do a very tiny thing. So no worries about progress. Seminar. We'll probably do it on campus on the meeting room we had last time, the 03267. Yeah, this is empty, so let's do it there. It does make sense if you bring pen and paper. We'll do some writing exercises. So that can't hurt. Or a laptop, I don't care, but something where you can actually write. And that might be useful. Okay. Any further questions? Nope. Then thanks for your patience on a Friday evening. I wish you a nice weekend.